explain how to use OPNFV testing tool to test and validate OpenStack provided by a vendor. Or it can be also Kubernetes, because now OPNFV deploy Kubernetes. I'm Valentin Boucher from Contourne, Canada. So I am software engineer, and I also contribute to Functest, the OPNFV project for testing. And Morgan Richaume.
Hello, everybody. My name is Morgan Richaume. I'm NAV architect at Orange, and I am OPNFV ambassador, and I'm not involved in on-app development and activities.
So the agenda for today, the first topic is OPNFV testing overview. So explain the testing chain and tools. And after that, both Contourne and Orange will explain the use case of reusing OPNFV tools. So OPNFV testing overview. And OPNFV CI complexity, it's really complex. We have some add-on feature. So for example, CVX function chaining, BGP VPN, DPDK, FDIO. So we have different kind of feature. We can have also SDN controller. So we can deploy Neutron with OVS without any SDN controller, but we can deploy Neutron with OpenDaylight or Honors or OpenControl, for example. We have different kind of installer to install in OpenStack or Kubernetes. So we have Apex, we have Compass, Daisy, Fuel, Droid, or the new one, it's Cross-CI. It's based on OpenStack Bifrost and OpenStack Ansible. And we have different kind of pod lab. So maybe 18, more than 18 around the world, hosted by Linux Foundation, Intel, Ericsson, Huawei, and other companies. So the testing chain, we have this different kind of scenario with OpenStack in iterability or no iterability, SDN, DPDK. We have different versions. So for example, basically we released Fraser last month. So the goal is to deploy Fraser and master and to do some bug fix on Fraser and do the new feature in master. We have the different deployer on pods. So the goal is to deploy each flavor and try to install it on the pods and test it after that with different test project. Push the result in the test result and do the report. OK, we have this kind of result for this scenario, version, deployer, and pods.
So if we dive a little bit more deeply into the OPNFV ecosystem, the project, we have several testing projects in the testing ecosystem. On functional testing, on performance testing, and even for performance testing, we have different projects dealing with different aspects of the qualification of an NFVI. So we test the performance, we test the storage, we test the vSwitch performances, the bare metal, etc. So we have a complete ecosystem of testing, and each project can be reused in CI chain and is currently used for the different CI in OPNFV. So we have all this project. We will focus how we reuse all this tooling. In addition of the project, we have also a test database and a test API. So we have a consistent way to report results from the different projects to the system. So it's relatively easy to have a good view. When you have lots of tests for test project, usually one of the problems is that you have different ways to get results. So you can have HTML page, XML, logs, whatever. And it's not easy to correlate all the information and to have a global view. So the idea was to have this global view using the tooling and to that all the test projects adopt this view. So I will detail only 2 test projects. So sorry, I know that there is a PTL of the storage project in the room, so you will excuse me. So we will detail, just give some highlight on the functional testing and the Yardstick project. So the functional testing project called Functest is supposed to answer to the question, does my infrastructure simply work as I expect? So we do not create lots of tests. We are leveraging most of the tests coming from the upstream. In OPNFV, our goal is not to redevelop tests that have already been developed in any of the upstream communities, but to reuse them and integrate them into a simple and light framework based on Docker Alpine, just in order to run them accordingly to the scenario we are dealing with. So as mentioned by Valentin, in OPNFV, the problem is just an integration project when you take bricks from different components. So you can have brick from the networking, brick from additional feature. And of course, depending on how you put that together, you can leverage a lot of tests corresponding to the ad hoc community. So for example, for the infrastructure, of course, we are running Tempest and Rally on all the different scenarios. But if we have a scenario with SDN VPN or BGP VPN, then we will have additional tests that we will run towards the system, and everything is automatically done based on the declaration of the scenario. So we have lots of tests. Most of them are coming from the upstream. And the tests are from basic connectivity checks that we use for gating. So the test can last 1 second just to check that the OpenStack is answering or Kubernetes is answering properly. To complex VNF testing when we integrate an orchestrator. The orchestrator will deploy a VNF. And once the VNF is deployed, we are also running functional testing on this VNF. So typical example that we share in the previous OpenStack Summit is a virtual IMS solution, which is a core solution for telco. Then we deploy it through different ways. We have different possible orchestrator. Then we deploy this VNF, and we run over more than 100 signaling testing to be sure that we cover most of the results. We are also able to run some stress tests if needed, but we have a complete chain of the deployment and the testing, the validation of this VNF. So, as mentioned, we leverage most of the time what is coming from upstream. We really develop things when we cannot find them in the upstream communities. So that's why we develop this VNF test. So today we have 3 test cases, one with VIMS, one with VPC, coming from OpenAI interface, but it's integrated in Functest, and one with a VIS router, and we have a complete chain. But otherwise, most of the tests for Kubernetes, we use the default Kubernetes suite that is used to conformance testing that is coming from Kubernetes. OpenDelight, we are reusing OpenDelight test as well. So the idea is also through the framework to be able to create a la carte, would say, test suite. So as a user of this tooling, you can decide, OK, I will take this test, put them together, and then we will run it toward the system as a black box and report the result to the system. So the PTL of this project is Cédric Olivier from Orange. OK. And that kind of result you can see. So that's the result of the different test cases. So we divide also, we slice the different category of tests from gating testing when we check only the connectivity, the API, basic API of OpenStack. We also are reusing a cable apps framework called Snaps in order to make basic tests. And we can have feature testing, we can have smoke testing. Then we are using Tempest, Rally, OpenDelight smoke test, and VNF testing. So at the end of the day, if we run all the tests, we can have more than 3 hours and more than 5 hours of testing. So that's why we allow through the framework to decide what kind of test I want for my infrastructure. As a telco, I'm not necessarily interested in all the tests. There are some tests that are doing the same thing, even coming from Tempest, for example. If you are using a RevStack or Tempest, or you may have an overlap, so you can decide what kind of test you are running. The second test project I want to highlight is Yastic. Yastic is a project that has been created at the beginning of OPNFV, and the idea was to answer to the question, qualify my NFVI. As a telco, so we are installing OpenStack solution, and the difficulty is to be able to compare Apple with Apple, peer with peer, and to get figure on the quality of the performance achievable by your NFVI. So the Yastic project has been created for that in order to rely on atomic tests and really able to give figure, to qualify, to compare the result with other tests. So the PTL is from Intel, Ross Brighton, and it's run also, it's in line with HCNFV testing. So there is a close work between standardization for this atomic test and the implementation in Yastic OPNFV. I just put one of the example here. For example, you have one test case, TC002, which is defined in ETSI, and the goal is to evaluate the network latency in a certain condition. And as we have lots of labs, we're able to run regularly on different types of hardware, different types of scenario, different type of installer combination, and we're able to graph that. So the difficulty is not from this figure to decide what is the right threshold and say, okay, that's the right figure that must be reached in order to be achievable, to qualify UNFV as a real telco cloud. Now the idea is to be able to compare your own value with the value we can have here, because in the galaxy or in the within the number of labs we have, some are really dedicated for performance, some are light, so it's normal that the value are not so good, but it's interesting to have transparently all these results and to be able to compare that in order to give you some asset on the qualification of your own system. So there are lots of test cases, and what I mentioned here, just here, that at the end, when you run one yardstick test case, as it is here for the TC012, which is on it's also a networking test case, then you can compare the influence of the integration of a controller, of a feature, of a lab on the results. So typically in Orange, when we install our first lab, the first value we have for this test case was about 3,000. And you can see that it's very low compared to the other, and it was a problem of configuration of our hypervisor. So we just tuned one value, and then we were back into 18,000. So just to mention, when you deploy an infrastructure as complex as OpenStack or Kubernetes, there are so many tuning parameters that your performance may be degraded by just one parameter. And then it's just a way to be able to say, OK, I'm in the average, or I'm below, or I'm above. So yardstick is very useful for that. And it's a way also to troubleshoot some possible configuration error. So yardstick is providing such testing, atomic testing in different domains, in compute, storage, network, for HAN and HA, and additional features such as SRIOV, DPDK, and huge pages. So you have a long list of that.
And in OpenAV, you can do certification of your OpenStack, commercial OpenStack. And the goal of Dovetail is to answer the question, do this product is conform to the interface, behavior, or functionality defined by OpenAV? And the main objective is to reduce the onboarding cost of a VNF. And same as other projects in OpenAV, the goal is not to recreate or create new test cases, is to reuse Functest on Yardstick and other testing projects in OpenAV to test the commercial OpenStack provided by a vendor. And we have the world the test scope. It's we have the world OpenAV test suite. So many kind of tests. And for the moment, Dovetail focus only on a part of this world test suite. So basically, in the first release, it's mandatory test case are a Tempest, so a basic OpenStack API test. Layer 2 packet forwarding, two VPing between VMs. And after that, OpenStack control service HA, so killing process and put some load on one controller and try to create VM flavor or other things. And the goal after, for the next release, is to extend the number of mandatory test case and optional test case by integrating, for example, a VNF lifecycle management test case. And so in the future, it will be more interesting. Just to show you the certification workflow, the first step is to submission certification form, so company name and hardware testing. And after that, we run a Dovetail test, so it's the technical stuff. For the certification, submit the result, and after that we can use or not the program mark if we are all green or no. So now the control and orange use case for using those tools. Control, just to show you, the context. The Control is a big company, but I work for Control Canada unit. So communications, so it's part designer for hardware designer, but also a software integrator on that hardware. So the big product, it's SIM Cloud, so it's both hardware and software solutions. So you have a solution for Edge, Core, SDN, DC, and it's mainly for telco, video and cloud also. And the goal is to make easy, to integrate OpenStack, do some configuration, and after that, click and deploy OpenStack, and also manage So scaling, upgrade, and integrate some add-ons like 6Win, for example, bare metal. So we have this different kind of flavor. Your problematics is to test and validate that OpenStack or Kubernetes, it's fine on this deployment. So we have different kind of hardware, different type of switches, different type of CPU with different core, and we have server with GPU, for example, or FPGA. We have also different kind of software types, so OpenStack or Kubernetes with different versions and different add-ons, 6Win, Ironic, and if we must also think about the future by integrating new OpenStack deployer, new SDN controller, for example, or new hardware. So the problematics is really near the OPNFV problematics. So currently, the current continuous integration process workflow is that. So we can deploy also HA or no HA, without or with Ironic, with 6Win acceleration or without. We have different kind of version. For example, for Kubernetes, we have the control version, so Arnold, Brittany, and the developed one. And we have the two software and different hardware. Now we use, basically we use Mason Juju to deploy OpenStack or Kubernetes. And we have a non-made test suite. No, it's not an OPNFV test suite. And it covers a lot of tests like networking, hardware test on Mason Juju, backup and restart, on many things. And after that, we do a report. And by this continuous integration, we can, after release a new version to sell to the customer. And we build an experimental continuous integration by integrating the OPNFV tools. So the goal is to put the Functest on yardstick after the homemade test suite, and the homemade and the OPNFV test will push the result in the same database, and after that we can get report of all of these results in the same place. And I can just show you the reporting. So for this reporting, we have the homemade control test for Kubernetes. So we have base check, E2E test, master HA, for example, or try to create a lot of containers. And after that, we can, your goal for that is to, why we use those tools in addition of the internal QA test, because your test suite is more diverse test coverage than OPNFV. So we are not only focusing on test OpenStack or test Kubernetes, but we test the installer. For example, Mason Juju, we try to do a backup and restart Mason Juju. We test the add-on. For example, 6Win, we do a lot of high perf test or hardware test, configuration also, change some IP and try to find if it works or not. And the OPNFV test suites are tests more related to NFV, for example, VNF testing. And in the homemade test suite, we haven't this test. So it completes the test coverage of the whole test suite. So it's really interesting to be better, to have a better OpenStack, better Kubernetes, and to be closer to the customer target usage. And also with that, we know that Dovetail will take more new take in the new version more OPNFV tests. So by passing in the CI all Functest and yardstick test, after that the new OPNFV verification, it's normally free because if it's all pass, we have the certification. So, Marion.
So we saw that all OPNFV tooling is reused by a vendor in order to qualify his product. Now we'll have a look at how it's used within a service provider. So in Orange, we have a pre-production platform, and we have also some anticipation platform. For the pre-production platform, the CI chain is very similar to the OPNFV chain. Basically, we reuse the best practice from OPNFV, and instead of just reusing everything that is in open source repo. We do not reinstall our system all the time because it's supposed to be stable, but we have our own Git forge in order to adapt the test to our own context, to create our own scenario. And based on that, we are triggering the functional testing and the qualification testing. We push the result in a database, and then we push. We have different web interface for the monitoring or for the release manager in order to see the status of the system. So we reuse massively the different test case. Here, just to indicate that in our ONAP Open Lab, so we have an ONAP Open Lab that is open to the community. Everybody can access to that. It has been installed using also the best practice from OPNFV. So we use bare metal OpenStack management. We use OpenStack Bifrost, OPNFV's cross-CI system. So based on that, we're able to reinstall completely the data center. On this infrastructure, we deploy on one side an OpenStack based on Collar and Siebel and a Kubernetes using kubespray. Once the different infrastructure are up and running, then we call the OPNFV testing tools. And we do not run Dovetail, but we run Functest cross-testing with different things. So we have more than 3 hours of testing every night just to check the stability of the system, including tests that deploy complex VNF, as I mentioned. So we just we deploy an orchestrator, we deploy the VNF, and we test it every day, run daily. And when this installation is done, these tests are done every night. On top of our infrastructure, either on OpenStack or on Kubernetes, we deploy, and we have also an ONAP solution. So ONAP, there are some presentation during the week, is an orchestrator. It's a new project in order to manage VNF lifecycle. So we deploy ONAP, and we adapt it also, the OPNFV framework, in order to be able to run daily tests on our ONAP. So we are leveraging the ONAP testing suite based on Robo framework, and we can run it daily in order to just have a good feedback on the health of the platform. ONAP is a really new project. The first version was end of last year, so it's still not so mature. Next release is planned in 2 weeks' time. Having this regular testing allows also us to control the stability. Sometimes we have some components that we need to restart, so we have the immediate feedback using our CI chain trigger also daily through our GitLab interface. So if we come back to the first picture showing the OPNFV ecosystem, we are reusing most of the pieces. I should add also, we made some tests with Strawperf or Qtip and Bottleneck a little bit. In the integration part, in the pre-production part, we did that. But in pre-production or in ONAP testing, we are reusing the tooling, the methodology with the CI integration, and as well functional testing and yardstick testing. So it's very easy. It's, as I say, based on Docker Alpine system, so it's relatively light, well adapted to CI/CD chain. When you have to build, you don't have a 2 GB Docker and say, no, it's really agile, it's less than 100 megabytes. So you can run it, you can customize them very quickly. And I think most of the projects in OPNFV testing, they adopted this philosophy, which is quite elegant and easy to reinstall. And the consistency, due to the fact that we are reporting all toward the same test API to a test DB, allow us to have a consistent view of all the system. So if I just made a comparison, OPNFV, we have 5 installers, 6 if we consider across CI. There's some debate about that, but there are lots of different installer ways to deploy the infrastructure. So we have only one way. So in our Orange Lab, we use Collar. In our pre-production, it's based on Director because we have some partnership with Red Hat. For the scenario, OPNFV deals with lots of scenarios. We are only consider one. So in pre-production, it's OpenStack plus Contrail. So that's why we need to adapt a little bit the test suite because Open Contrail was never really validated in OPNFV within a scenario. So we have to exclude some tests that make no sense with Contrail. And in ONAP, we are just reusing basically without any SDN controller. And for the testing, I say for the moment, mainly Functest and Yardstick are reused. And recently, as we had to provide this open lab for ONAP community members, we decided to reuse Functest cross-testing in order to adapt it, in order to be able to run ONAP test exactly the same way we did for the infrastructure. So using the same Docker framework, we are able to run the test and to have the same feedback at the end of the day. So we need only 3 files to do that. So it takes less than 1 day because the framework is really easy to adapt. And we have 3 text files just leveraging and cloning the existing, and then we were able to inherit all the consistency from the different tooling coming from OPNFV. So less time. And you can see here on the top, that's a picture. That's on app. We're using exactly the same thing, doing some feedback. It's pushed to the DB, and here we have a graph and an overview of all the different basic components of ONAP. If you already play with that, you know that are core a lot. And the monitoring of each component individually is interesting just to know which VM you have to connect to. And on the VM, usually you have several Docker, and sometimes you have to reinstall that. Of course, it will change with the new version of ONAP because we are based only on Kubernetes with a framework mainly developed by the Amdocs people. So we may expect that when something is fault, it will restart the Docker. But anyway, it's interesting to have this view because even with Kubernetes view, when you keep on restarting things that are failing all the time, that's not the way to solve problems. And that's what we have so far. So, conclusion. As a conclusion, is that OPNFV testing tool, testing ecosystem is very useful. It's very evolutive, easy to integrate. I think it really follows the rule, which was upstream first. We didn't redevelop, we didn't see lots of tests redeveloped that were not in the upstream project. So it means that there are lots of connection, and people who are involved in the testing project need also to, when they start doing something, to see upstream if it's not already covered. So you need to have a wide view on the different project on your ecosystem. But it's interesting and it's easily adaptable even for an infrastructure which is not an OPNFV infrastructure, which was the case in our case. In Orange, as I mentioned, we deploy our OpenStack using either a Red Hat director, which is vendor product, or a Collar Ansible, which is an official OPNFV installer, even if the Daisy installer is based on Collar, so there's some connection. But automation is key, and that's really what we wanted to do. So the framework with Alpine Docker, very light, very easy to set up. The database, which is also Dockerized, the test API, which is also Dockerized. So you can set up a complete ecosystem for testing within a day, and then you can start just, you can have several platforms, and you aggregate all the results in the database. With the API, you can filter, and you can compare the different things. So that's quite powerful and interesting, but automation is very key. The tooling is reusable, of course, out of OPNFV, as I mentioned. So that's, for example, a control, even if you use Mass and Juju, it's not Redroid, which is also an installer in OPNFV. But we show that we can easily readapt it. Regarding Dovetail, as you mentioned, for the moment, there is only a subset of the testing. So that's because it was the first iteration for this certification program. We may expect that it will grow. In Orange, we use much more than what is defined as default because we want to have also the VNF. So we use a wider scope. But of course, we need a consensus in order to know what makes really sense for our certification. So the Dovetail project is working on that. But that's clear that today there are lots of additional tests that could be added if needed. We just need to understand what makes sense, what is achievable. But from my perspective as a telco, I would expect to include the VNF testing in addition of just the smoke test. So the idea is not to test the VNF itself. We don't really care. We use the VNF deployment just to test the infrastructure, but we want to be sure that the infrastructure is able to deal properly with a realistic telco workflow with test cases such as IMS or EPC. Okay, so that's the conclusion for today. I don't know if you have any question. Yeah.
Since you're using existing tool, what's the main challenge using this existing tools available in OPNFV?
The main challenge, so I think it was relatively straightforward. I think one of the challenges, of course, the maintenance over the release with this crazy cadence of 6 months for every project. I know that at the moment in OPNFV there are 2 different tracks for the release, so it's complex to be sure that everything will be maintained all the time. And for example, if you consider the VNF testing, in the previous version, we have a deployment of an IMS using OpenBaton orchestrator, and the team OpenBaton was not able to maintain it, so it was not possible to run it for the last release. So there is really a question of maintenance and the effort people want to show some test can work on the maintenance of the test. So that's a challenge. But otherwise, for the integration, I think it's relatively simple and much more simple than at the beginning of the community. I think we are at the release 5 or 6 now. Yeah. So the community gained in maturity regarding the testing framework. I know that just after there is a presentation from China Mobile, I think they have also they share a little bit same view on the fact that we can reuse this tooling independently from what has been deployed or installed through any installer. And it's useful for us because one of the key problems or key issues is the trustability into the system. It's so modular, we have so many things that just running once a test suite is not enough. If you run once Tempest, for example, you can get good result, and you run it 3 or 4 times, then you will have problem. Or the same for ODL. We detected that resources were not properly free. So we had issue at the end because we have resources that were locked and things like that, and we can see that only with this kind of test. So it's very useful to have this kind of tool available for telco, at least for telco. Mm-hmm. So I don't know the challenge for the vendor. How do you see that?
It's the same, reuse, test, and test something that not already done in OPNFV. And the goal after is to reuse the test, but to push new test case. Semi-orange create VNF test case, for example, but also we can create a new test case in order after that to put in certification, for example. So the goal is more that, and improve the tools. It's really interesting. Maintain also, and find if we have any issue in the deployment. Yeah.
Troubleshooting is also not done. When you run this test, when you have 3 hours and 30 minutes of test, and at the end of the day, among the, 1,000 tests, there are 3 errors, then troubleshooting is not easy. And we don't have really tooling for deep troubleshooting. Of course, we can collect and aggregate all the logs. So we have logs in OPNFV tooling, but sometimes we need to have also the aggregate logs of the system. So it may take time. So when everything is fine, it's fine. When you have some problems, then you can take time in troubleshooting. But what is pretty interesting is you can easily resize your OPNFV tooling, at least for the functional testing. And when you say, I just want only to run one test case, and you can isolate, and you can replay it in a predictable way. So that's also interesting for troubleshooting in this case. I mentioned with the Yastic test case, at the very beginning, we detected that we have a misconfiguration in our hypervisor. And people, when they did regular tests, they didn't see that because everything was working. It was just very slow in some conditions, and due to this misconfiguration. And Yastic was able to check for the network storage what is wrong, or at least what could be seen as wrong. And the fact that we have this federation of labs and we have tests running all the time, we have, I don't know how many scenarios are run daily, but there are lots of scenarios run daily. So that's this picture, which has, I think, lots of value, at least more than today we consider. And I know that in Yastic they plan to integrate it for something more integrated, but here you can really see if your system is totally wrong regarding lots of parameters. And it's very useful for us, because otherwise it's hard to have a clear diagnostic on that. And yeah, very useful. And it's not an error, it's just misconfiguration. And misconfiguration, sometimes you don't get any error. You will get side effect, and of course, you can have very difficult things to troubleshoot on. Yeah, 3.
Are the ones that you run in production?
No, I don't know. We are a service provider, so no. We are running. That's the same that are running in OPNFV. So they are all open source VNF, but they are very realistic. If we consider the VMS, it's based on Clearwater VMS. So we could imagine to put that in production today. That's just a question. Also, we need time to change our mind in some thing. But I know that some service provider already put that in production. So it could be put in production, and we have the complete deployment. Now we are also working on ONAP in order to have the full picture on the full life cycle. But the VIS, VRouter, and the VMS could be in production. The OpenAI interface is just a core EPC. So for the moment, of course, due to the complexity of the system, usually we will, of course, purchase and deploy in production a VPC, probably coming from a vendor. We have to imagine it's more the VPC for OpenAI interface has been designed mainly to work on 5G and to work collaboratively with academics and with all the stuff. So that's not planned to be in production. Unlike Clearwater VIMS, which is already in production in some company, but not in our company at the moment. Yeah. Yes?
The stability of the test, have you found that you get a lot of false negatives during the test where you would run it and it would fail, but because of the test and because of the
Okay, so that's a good question. And I expected at the beginning that we got lots of false negative. And sometimes when we have, because we run daily this 3 hours of 30, and at the beginning everything is perfect. And when we start getting false, the first idea is, okay, that should be a false negative because we have some, I don't know, during the night, some connection issue or whatever. But for the moment, I mean, it's running since at least 6 months daily. And every time we start getting an error, we had really an error. And it was due to, for example, Ceph. We had some issue with Ceph at one stage. We had some issue also with Nova Console. We have some issue with, every time there is a good explanation on the infrastructure.
Network issue?
There are also some network issue, but we didn't get false negatives that say, okay, we didn't get, we didn't get. So it was really interesting to get this error in advance because sometimes it's just detecting something that starts going wrong. We have an HA system. So the HA system, it works well, but sometimes just restarting one of the controller, and then everything is back to nominal, and we have true everywhere. So that's quite funny, but funny. I don't know if it's funny because it seems that the system, even the infrastructure, which is now supposed to be very reliable, it's not so reliable. And one of the problems is probably due to the fact also that the cleaning of the resources is not so good. And that's something we reported to the testing tools. When we are deploying an IMS, we are deploying lots of things, networks, some networks, and sometimes cleaning is not done as it should be. And then we have remaining volumes that are in pending state, and that's when we have accumulation of these things, and we can see that over some weeks. Like, okay, we start seeing that volume management is degrading because probably there are some things that were not cleaned properly. So that's something we reported, and that's one of the goals for I think, the testing project for next, to clean a little bit better. And there is a framework for OpenStack to do that more properly than they were doing. Because as we had this issue, we create a script, and then we clean it a bit widely, because just to be sure that we do not keep too many resources.
Thumbs up.